Now, I want to change subject a little bit because one of the things that's happened since I've started in this project is we've met some pretty crazy and some pretty interesting people, and this is certainly one of them. He was one of the early people to sign up for a ticket to space. His name's Philippe Starck. He is a very famous French designer, and he's also very passionate about aviation and aerospace and very passionate about what we're doing in order to improve space access and open space to ordinary people. And one of the things that Philippe did was to offer his services to us and said, look, I'd like to really help you with branding and design because I think it's very important that the way you're seen is really reflecting what it is that you're doing in the longer term. And he came up with our rather nice Iris logo, and he also came up with a sort of secondary logo which he calls the DNA of flight, because Philippe's view and our view is that there is a continuum here, that man's desire to explore and to travel is very much in our DNA, pushing boundaries, exploring new borders and continually on the urge to discover has very much made us the species that we are today, and that the history of aviation and space travel is a perfect example of that. And what I thought I would do is just to sort of trace that quickly, just to give you again the context of what it is that we're doing. So you have a little DNA here, which is made up of different aircraft and spacecraft, and actually the first one is a person with wings, and of course that's Icarus. And this really shows, I think, that the desire to fly, to rise above the world has been in man's dreams really since time began. And this, of course, is a lovely legend. And the thing that I like about it more than anything else is that, of course, Icarus did fly very successfully, and the only thing that really let the whole project down was that he was having such a good time, which I think says a lot about flight and exploration. We then moved to 1,000 or so years later, and to the Wright Brothers, who right at the beginning of the last century at last cracked that huge challenge, which was to provide powered heavy-than-air flight. And they're a remarkable couple of guys, and it's well worth reading the history of this because they went through terrible times when they really believed that they would never achieve what they were trying to achieve. And in fact, I think just a year or 18 months before they had that first incredible powered flight, one of the brothers said to the other that he thought it could be another 1,000 years before the dreams were achieved. So the determination and the keep plugging away and the eventual success, was a huge milestone in what we're doing today. And the incredible thing, of course, was that after hundreds, if not thousands of years of people trying to do that, as soon as it was done, things moved on very, very quickly. And within a few years, you had hundreds of pilots around the world traveling around in small aircraft, mainly barnstorming for pleasure, the start of early commercial services. But it was this man, I guess, that could really be credited with the start of commercial aviation. He really lit the match that created the fire that we know today. And he, of course, is Charles Lindbergh. Now, Charles Lindbergh flew across the Atlantic single-handed for the first time from the US to Paris in 1927 in an aircraft called the Spirit of St. Louis, and it was a pretty remarkable achievement. Interestingly, he wasn't the first man to cross the Atlantic by air. He was actually the 101st man, which I certainly never realized. But the first were two Brits, of course, Alcock and Brown, who did that in 1919 and landed here in Ireland. But nevertheless, Charles Lindbergh's flight was something very special because he did it on its own. And he really provided the proof of concept that flying could be used for maybe something else other than just pleasure and the barnstorming and fun rides. And it was really that flight, for whatever reason, that you can trace back to the birth of commercial aviation. Sorry, wrong button. As far as space travel was concerned and supersonic travel, and of course if you're going to go to space you've got to be at least going supersonic and many times that in most cases, it was probably this guy, Chuck Yeager, in 1947 that was responsible for challenging the demon that was known as the sound barrier. It was called the barrier because there were many people that felt that it just wasn't possible for the human frame to withstand going faster than the speed of sound or any machine indeed to do that. Chuck Yeager was again, the right stuff, of course, and he was a remarkable guy, prepared to take incredible risks, and actually broke his collarbone the night before the flight, but was so determined to do it, he hid the fact, got in the plane, flew, And really that flight and the flights that came after, which showed that you could fly at supersonic speeds, was the sort of paved the way for the early days of space travel. I must get this right, sorry. Commercial aviation, of course, it started with Charles Lindbergh, perhaps. It became a preserve for the rich, pretty much, for many years. And it was really this aircraft, probably more than any aircraft, that really heralded the start of mass commercial air travel that we know today. It was put together by Boeing, of course, and it was from an order by Pan Am. Juan Trippe, who was probably the greatest entrepreneur in aviation in history, asked Bill Allen from Boeing to build him an aeroplane that was 30% bigger, but would actually cost about 30% less per seat to run. And there was the famous interchange where Allen said to Trippe that, Trippe said to Allen, if you build it, I'll buy it. And Allen said to Trippe, if you buy it, I'll build it. And he did, and it was a remarkable aircraft. Interestingly, on that aircraft, you might not know this, but it was built in such a way that had the big bulge on the front because they thought it would have a very limited lifespan, probably 4 or 5 years, after which it would be overtaken by supersonic travel because Concorde was on the way then, of course. And so it was designed so that nose would open and it would become just a big, slow cargo plane because they believed there'd be no interest in anything other than supersonic aircraft for passenger travel. It actually became the largest and most popular aircraft, for about 37 years until the A380 took over last year. I think it's an icon now, and probably no other aircraft represents the way that aviation has progressed from a sport to a pursuit for the rich to an industry which has really changed the world. And that gets us to the giant leap for space. And as I say, the 1960s was a remarkable decade. NASA was a fantastic freewheeling risk-taking organization. They were given a very clear mandate by JFK at the beginning of the 1960s to put a man on the moon and bring him home again safely by the end of the decade, and against all the odds, because it was a crazy thing to say. I mean, it was an impossible dream, but NASA managed to do that. And certainly some of my earliest memories, and perhaps some of yours as well, is seeing those incredible black and white pictures of both Buzz and Neil stepping onto the moon, which still, I think, have the ability to inspire and amaze. So that brings us to our part in the history of aviation and space. Now, this is a picture that we see all the time. We're also always seeing pictures from space. They're used in advertisements. They're used for logos. They're used all over the place. And it's been a little bit ironic, I always think, that so many people know what the Earth looks like from space, but actually an incredibly small number have actually seen it with their own eyes. And, we're still less than 500 people, or fewer than 500 people, since the beginning of the 1960s that have managed to break free of this Earth's atmosphere and get into the world beyond our world. Now, this picture of space is a very different picture of space because it wasn't taken from a government satellite, it wasn't taken from a government-employed astronaut. It was actually taken from SpaceShipOne by a private pilot called Brian Binney. And SpaceShipOne, on the 4th of October 2004, became the world's first privately designed, privately constructed, and privately flown spaceship to put a man in space and bring them back again. It was a remarkable achievement. And why was it such a remarkable achievement, and why was it so important? Well, because Houston did have a problem. They achieved, as I say, NASA did some great things in the 60s. It had a definite mission. And perhaps, it's debatable about why and what happened after that to manned space travel. But I think in some ways it lost that sense of mission. It became a little bit confused as to what the logical next step was. And it still remained very, very much the preserve of the military and of government agencies. And the big issue that we had as a budding space line back at the beginning of this century was that we needed vehicles that were capable of accessing space with ordinary people in them and coming back safely. And we also knew that we had an imperative to be a commercial success. So we knew that we had to keep people safe, and we knew that we needed to make money from the pursuit if we were going to be able to start a new business and a new industry. And looking around, which we did for 2 or 3 years after Richard made that first announcement, it became very clear to us that the existing technology all around the world was completely inadequate because it was all based on ground-based rocket technology that had been produced pretty much during the Second World War. There had been no innovation, there had been no development really in the way that things and people had been sent to space over that 50-year period, which is extraordinary. And here's a good example. I mean, this is the monster of rockets really, the Saturn V, but it's a very good example of how the mindset has been about getting things into people into space, which is that you build a huge tower of a rocket. Almost all of it is full of fuel. So the people, of course, sit on that bit that you can hardly see right at the top. And most of that fuel is actually used in the initial stages of the flight, and it's used in order to punch your way through the very thick atmosphere and reach velocities that are required to get into orbit. And the great problem with this, of course, is firstly that causing an enormous explosion at ground level where the oxygen is at its thickest is a pretty dangerous thing to do. The rockets that are used here and are still used in this picture and are still used today for the shuttle and for Soyuz are solid rocket motors, which are very much like garden fireworks. And the big problem with them is that although they're pretty efficient at what they do, if you want to turn them off, you can't. So once they're lit, you're committed. And so if anything goes wrong, anything goes amiss with any part of the technology in those first few seconds of flight, the people at the top need to get ejected very quickly, and they're ejected at an enormous amount of Gs. And it's survivable, just about, but it's not the way that we could treat fair-paying customers. So we knew that this sort of technology was not going to meet our objectives of commercial viability and safety. The other problem with this, of course, is that it's hopelessly, environmentally damaging. I mean, the energy used to get the shuttle into space is roughly equivalent to the energy used by the city of New York for a weekend. And these missions take months and months to prepare. They cost hundreds of millions. And the great shame about it, in this day and age, of course, is that the whole lot is thrown away at the end. Nothing survives. That, again, is not any model for a commercial business. It's a bit like with our airline, Virgin Atlantic. Every time we flew a 747 to New York, we dumped it in the Hudson River and had a new one to come back again. You can't run a business by throwing the technology away every time you've used it. So there was a big issue out there, and we got a little bit concerned about that because it didn't seem that there was really anything anywhere around the world that had any capability of being commercialized. However, that changed, and it changed because of another kid from the 60s, a guy that Virgin didn't know. I mean, he was doing things independently. This is the man. He's called Dr. Peter Diamandis, and he was another kid from the 60s who was getting very frustrated about nobody taking him to space. He wanted to go. He couldn't see why he couldn't go, but he wasn't being given the opportunity. And so he actually was inspired by the story of Charles Lindbergh, funnily enough. And if you ever read the story of Lindbergh and the Spirit of St. Louis, you'll realize that Charles Lindbergh was inspired to make that single-handed flight across the Atlantic because of the existence of a prize. And actually, if you look at the history of aviation, a lot of the milestones were because of prizes. And the great thing about prizes is that they actually open up the potential of everybody. If you put up a big prize and say, this is what I want to achieve, if you can achieve it, whoever you are, wherever you are, then you've won the prize. Then you're really sort of extending the potential enormously of that job going done. If you just go to Boeing or Northrop or whoever it is and say, this is the job I want done, then you're reliant just on that group of engineers being able to have the ideas. So Peter thought, well, this is a great idea to perhaps break the cartel and break the stalemate that we have in manned space travel. So he managed to raise $10 million, and he said to the world at large, here it is, the X Prize. Anybody that can build a spaceship, a suborbital spaceship, privately, no government help at all, can build it and then fly it to space and back twice in the period of a fortnight with a man on board, you've got yourself $10 million. And it seemed a very simple plan, and suddenly he inspired engineers, designers all over the world to have a go at this. And one man who put his mind to it, surprise, surprise, was another guy, a kid from the 60s, a man called Burt Rutan, and this is Burt here. Now, Burt Rutan is probably one of the few people that I know or have met that I would consider to be a genius. He has designed and built the most innovative and amazing aircraft, both for government and for private use over the past 35 years. He has a unique understanding and ability to use carbon composite materials in aviation. And Burt was pretty confident that this was a $10 million that he would be able to win reasonably easily. He had other worries about the prize, but he thought he could put his mind to this. And interestingly, as far as Virgin was concerned, we were working on that global flyer project I talked about earlier on, and we became aware as we were sitting in the factory with Burt looking at the global flyer that there was a funny little vehicle under wraps in the corner of the hangar, and we persuaded Burt to tell us what it was. And he said, well, I'm competing for the X Prize, and I've got a pretty innovative way, I think, of getting to space and back. And the more that we got to know about how he was going about it, the more excited we got, because it seemed to us that he had solved, in a particularly brilliant way, these huge issues about safety and commercial viability. Now, strange slide to have up here, but the way that Burt went about thinking about this, and I think this is a really good lesson for all those involved in innovation, design and science, was that he was prepared to look back in history for great ideas, but for ideas that were ahead of their time. And this applies not just to aviation. I put this slide in because it's one that my boss, Will Whitehorn, always insists we use. His grandfather designed this strange little car back in 1927, and it was actually the first petrol-electric hybrid car. And it was way before its time. The battery technology wasn't adequate. Petrol was incredibly cheap. Why did you want to mess around with batteries and electricity anyway when you had this unlimited supply of fossil fuels? But it actually worked. It wasn't, of course, until 70 years later that the commercial version came along in an era when battery technology and technology generally was far advanced. And, of course, you had an impending fuel crisis which actually made the thing marketable and desirable. And the reason I say that is because there was a project that Burt Rutan was working on during the 1960s called the X-15, which he had always been very attracted by. And this was a project which was actually abandoned in the end by NASA and the US Air Force because it was, again, a bit ahead of its time. But the thing that Burt loved about it was that it got away from this idea of having to have enormous rockets that had huge explosions at ground level punching their way through the atmosphere. It actually was a space aircraft, a space plane, that wasn't launched from the ground at all. It was launched from the air. So the X-15 used to go up on the bottom of a B-52 bomber, was launched at high altitude and powered its way into space, and successfully on a number of occasions. And it sort of worked very well. The problem with it was actually quite dangerous, particularly because of the weight of this space plane. They had to be made out of very heavy metals because there was no alternative material at that time which would be strong enough and resilient enough to withstand the forces. What Burt had at his disposal, of course, was carbon composite material, which changed all that. So the first thing, if you look at the left-hand side of the screen from where you are, is that we go for air launch, not ground launch. So we actually built two vehicles, a carrier aircraft, which we call White Knight, and the spaceship, which we call Spaceship 2. And the carrier aircraft goes up to 50,000 feet, and it launches the aircraft at that level. Just that alone makes the technology thousands of times safer than launching from the ground. If everything goes well at that point, the pilots of the spaceship fire the rocket motor, and you accelerate very, very quickly. For those inside, that's the big kick. You go from about 140 knots of airspeed to the speed of sound in less than 8 seconds, and then you keep accelerating to 2,500 miles an hour, going straight upwards into space, powered by a very powerful but a very safe hybrid rocket motor. A hybrid rocket motor, again, is a great idea from the past that has been developed for this vehicle. It consists of nitrous oxide, which is a benign gas, and rubber as the fuel. Those two elements are very stable in their own right. Even when you mix them, they don't do anything. But when you force the nitrous oxide through a hole in the rubber core and ignite it, you get a nice, powerful rocket motor, which is more than sufficient to get us up into space. Once you're up into space, something really clever happens, and you heard Burt talk about that on the video. One of the really big issues about space travel is coming back into the Earth's atmosphere, because those who have done physics will know that basically you come down at the speed that you went up, and when you hit the Earth's atmosphere, you develop a lot of heat. And in the old days, they used a capsule which was pretty much bomb-proof. It came down on a parachute, splashed down in the sea. You threw it away and built a new one. The space shuttle tried to get over it by flying into the Earth's atmosphere, which worked, providing that you're able to keep a perfect trajectory, which relies on sophisticated computer flight control systems. What Burt wanted to develop was a foolproof system that didn't rely on pilots or computer-controlled flight systems, and would also be reusable, could be used time after time. And for his inspiration, he took the humble shuttlecock. And for those that play badminton, you'll know that if you throw a shuttlecock up into the air, regardless of which way it starts to come down, even if it's upside down, immediately it starts to come down. It will turn itself always, it will right itself automatically so that the ball of the shuttlecock is always facing downwards. And that's just the law of physics. The other great thing about a shuttlecock is that the feathers act as air brakes, and so the rate of descent is controlled and slowed. Burt thought if I could change the shape of my little space plane by rotating the wings through 90 degrees, so those wings become like the feathers of a shuttlecock, then it's just possible that whatever angle I come into the Earth's atmosphere, the spacecraft will automatically be turned, so it comes down belly first, and that those inverted or rotated wings will act as giant air brakes and will slow the spacecraft down in the very high atmosphere so it never builds up any sort of dangerous heat, and the pilots have to do nothing. This is something which is going to be completely reliant on the laws of physics, not on computers which can go wrong or pilots who are fallible. And so he designed it. He put it into SpaceShipOne. He put SpaceShipOne into space, and it worked perfectly. So with that, Virgin Galactic was born. Burt Rutan did what only three of the world's most powerful governments had done before, which was to put a man in space. And there was a huge opportunity. Now, the SpaceShipOne now hangs at the Smithsonian Museum between the Spirit of St. Louis and the Bell X-1, Chuck Yeager's Bell X-1. In pride of place, which shows just what an important achievement it was. Burt's real concern at that point was that would be the end of the story, that he'd done something amazing, and that would be it, and it would still be just as hard for you and I to go to space. And so he was very keen to meet somebody that might be able to go to the next stage. So he needed the final part of the story, which was the entrepreneur. And so we came along. We believed that this technology was so different and so much better, had all the key ingredients needed to make commercial, safe space travel for ordinary people a possibility. We signed a licensing deal and we started work on designing and building the next generation of vehicles, Spaceship 2 and White Knight 2.